Emotion monitoring systems can enable plentiful of applications. In particular, it plays an important role in improving the mental health conditions for the general public. They help psychotherapists diagnose and develop better treatments for patients, as well as inform the general population of their own mental states. It will also enhance the lives of people by bringing, for example, enhanced entertainment experiences when movies, games, and TV shows present dynamic content to the user based on the emotions experienced by the user in the real time. Moreover, emotion monitoring platforms also help to measure the effectiveness of the advertisement and can having the advertising tailored to the user's emotion. To bring the emotion monitoring systems out of the lab or clinical settings and make the aforementioned applications more approachable to everyone and maximize the effectiveness of the applications, we present Spiders Plus, which is a system for processing in situ biosignal data for emotion recognition and sensing, which targets at detecting two phases of emotions, apparent emotion and real emotion, where apparent emotion is your facial expressions and the real emotion is like the arousal and valence level of how you feel internally. Spiders has a 4-layer system architecture. Each layer in the architecture directly enables the applications or functionalities in the layer directly above. We take a top-down approach in designing Spiders Plus based on the types of applications we aim to address. The advanced functionalities layer include the two phases of emotions, as I mentioned before, while the core function library contains the features working towards advanced functionalities. All the hardware sensors and the filaments we use to 3D print the Spiders Plus glasses frame is less than $20, and the entire weight of Spiders Plus with all the boards, sensors, and battery installed is below 100 grams. And using a 2000 mAh battery allows Spiders Plus to continuously run for more than 9 hours in our battery life test. The core function library contains a landmark generator based on a convolutional neural network with 8 convolution layers, which generates 27 landmark points to locate the eyebrow boundary as well as upper and lower eyelids. The core function library also contains a pupillometry detector, which detects pupils' pupil, and a zygomaticus muscle movements detector, which leverages the movements of the smile muscle to detect whether the subject is smiling or not. We leverage the pupillometry to conduct a real emotion classification to tell the user's arousal and valence level, which refers to how agitated or happy the user is towards a certain stimulus. We use the results from the landmark generator and an optical flow detector to detect 5 classes of facial expressions. The performance of both facial expression and real emotion detections excel the state-of-the-art approaches, and both like those detectors in Spiders Plus are lightweight enough to be implemented on resource-constrained embedded platforms. We also prototype some applications that could be enabled by Spiders Plus. For example, we can use the eye shape and pupillometry information for fatigue detection. The fatigue detection can be further leveraged for safe driving applications. We also present a desktop application and a smartphone application to visualize the results from different function modules in Spiders Plus on a user panel. User can easily view their mental health status and the results from Spiders Plus in the application.